Hello guys, this is Mike from McProgramming.org. I wanted to make a video on just generically what is Java and what happens when you run a Java program. Well, Java is obviously a programming language. It was developed or appeared for the first time in 1995 and created by James Gosling at Sun Microsystems, but it is currently owned by Oracle. And there have been 7 versions of Java. If you download the JDK, you're going to get something like JDK 1.7 and some more stuff. But the JRE starts with 7. So this 1.7 means that it's the 7th edition or 7th release, and JRE just automatically starts with a 7. So I don't know what will happen when it changes to 2.0, but the 8th edition is actually on its way within a couple of months. So I believe in April maybe it's coming out. So you don't have to, but you can download the new Java Development Kit and the new JER. And some features of Java are that it's object-oriented, which means that you can try to simulate real-world objects into a computer program. It's multi-paradigm. It's structured, imperative, generic, reflective, concurrent. Concurrent means that it supports the use of threads, which is a great characteristic to have of any programming language, because you can do multiple things at one time. Your processor can deal with a bunch of different code simultaneously, so it gets tasks done a lot quicker. The way a computer works is it only reads binary numbers, and binary numbers are zeros and ones and zeros and ones, and a bunch of that. That's what your computer reads at the CPU level. But in reality, zeros and ones is almost an abstraction in itself, because it's the 0 and the 1 represents electrical currency, and when it's getting sent, like if the currency goes up on a graph, it's a 1. If it goes down, it's a 0. So it's really just this electrical pulse, you could call it, that runs your computer. But we type with words, so when you say for for loop, and you're saying ni blah blah blah, all of that is really zeros and ones covered by what's called data abstraction, and that makes it a lot easier to use human readable form. But let's talk about what happens when you compile your program, which, if you haven't done this yet, you're going to need to know how to do this. I teach Java and Eclipse, so you're not really coding in the compiling code that you would run on the command line. But if I was to run something on the command line, I would write a Java program, and it would have to have a .java extension for your compiler to recognize it as a Java file. And I would say Java C, which is the Java compiler. And granted, all this will only happen if you have both of these in place. So now let's just say we said hello world.java, and then you would hit enter, and then what you would do is you would end up with a program called hello.class. And what hello.class is bytecode, Java bytecode, and this is it's binary, but it isn't subject to your particular operating system necessarily. What it is subject to is the Java virtual machine. So that it runs on a Java virtual machine, which exists inside of this Java runtime environment. That's why you have to have this, and that's why if you haven't programmed before but you do need to download Java all the time, it's probably because there's certain Java applications that are online that won't run because they need to run on a Java virtual machine, so it mandates you to download a JRE. So that is why you have to download all those annoying Java updates constantly. But anyways, so now you have this bytecode, hello.class, and what this is, like I said, is zeros and ones again. And when you download the JRE, you have to tell the download source if you have a Windows, or if you have a Linux, or if you have an Apple. And the reason for that is that the Java Virtual Machine will directly talk with your operating system, depending on what it is, because if we didn't have this virtual machine, we would have to recompile this code on whatever machine we're on. Whether we're on a Windows or an Apple, we would have to recompile it with a compiler that's compatible with your operating system. So this makes it easy. This makes it cross-platform. It means that you can run this code on any system that just has the JRE, which holds the Java Virtual Machine. So that makes it pretty useful. And once we do that, if we're still in the command line, what we do is we say Java hello, you take off the .class. You don't want to have .class, and you run that, and it will run that bytecode on the Java Virtual Machine, which will interact with your operating system, and your computer program will work. So that is what happens behind the scenes at the very basic level. There's a lot more to it, but that's as basic as I can get. I don't want to overwhelm anybody, but I do want you to appreciate the fact that when you're making your programs, you're not writing like this. All of that's hidden by Java's syntax. So that's nice. You don't have to worry about that. You don't have to worry about, such as in C++, there was pointers and you had to directly deal with memory location. We don't have to deal with that. We just create objects, and we have what's called a garbage collector. And what that does is when some object or variable that you created but you don't use anymore, automatic garbage collector will retake that memory space and give it to something else. So you don't have to worry about filling up your memory and dealing with when you stop using something. You have to delete it and free up that memory space again. So there are a lot of advantages to using Java, but there is no such thing as one language fits all. So Java works and great for a lot of things. It's probably the most popular language at this time. That's debatable. A lot of people like C++, people like Python, but Java serves its purpose in a lot of ways. It has its weak links in a lot of ways. But this is what I hope you enjoy, and I'm willing to teach this to anybody who is willing to learn. So thank you guys for watching, and please subscribe below.